R4a. Now we will be adding and subtracting fractions. And if I said, what's the difference between adding and subtracting fractions and multiplying and dividing fractions? Many of you will say, well, you do need a common denominator when you're adding and subtracting fractions. So let's take a look at that. And before we do, what I like to do is, there are principles that are common to many applications in math. And one of them that applies to adding and subtracting fractions is the following. So this is you're going to see this over and over in math. The idea is you can only combine. And what do we mean by combine? Combine just means where you can add or subtract together. You can only combine like things. So for example, if I said, what is 2 dogs plus 3 dogs? Well, we're adding the same thing. We're adding dogs to dogs. And everybody go, well, that's easy. You have altogether 5 dogs. Likewise, if I said 8 dogs minus 2 dogs, well, I don't know, those 2 dogs ran away, so now we just have 6 dogs. And please notice that when you add and subtract, whatever you're adding and subtracting stays the same. We had dogs, dogs, and we're going to end up with dogs. Let's take a look at, what if we had 2 dogs plus 3 cats? Can you find a simpler way to that? Well, you can't really say anything more than, well, I have 2 dogs and 3 cats, because these two things that you're adding are not like things. One suggestion you may have is, well, could you change dogs and cats to something that they have in common? So you could say, yeah, that would be equivalent to saying I have 2 animals plus 3 animals. So now we can say, okay, what we have is 5 animals. And again, you can only add and subtract like things. Okay, I'm going to do a little bit of erasing here and show you the parallels between this idea of dogs and fractions. Well, let's just go to a new page. Okay, so recall from R3 introduction that the numerator of a fraction indicates how many you have, and the denominator really indicates, well, of what. So in this case, when we see the fraction 3 over 4, it says we have 3 of these things called fourths. So it's 3 fourths. So that's why we can add 3 fourths plus 2 fourths, because we're adding like things. And we would end up with 5 of those things called fourths. Okay, back to the dogs. Like we said before, 2 dogs plus 3 dogs equals 5 dogs. Nothing changes in what we're adding. This is the same kind of problem as 3/7 plus, let me change that, 2/7 plus 3/7. What do we end up with? We end up with 5. What are we adding? What kind of things are we adding? We're adding sevenths. So to indicate that, we can just throw that 5 over 7. Okay, so then we had the issue of when we had 2 dogs plus 3 cats. And then we changed that to something that they both have in common. Here's where the analogy breaks down just a little bit, because we found that we could say that's 2 animals plus 3 different kind of animals, but still animals, and we would end up with 5 animals. Okay, the idea that I want to get across here is you can change what you're adding, call it something different, so that you can say that you're adding like things. Okay, the equivalence of that is in fractions when we don't have a common denominator to begin with. So if we take the example, I'm going to make it kind of complicated. 3/8 plus 5/12 minus 1/4. So we're adding 3 of something called eighths plus 5 of something different called twelfths minus 1 of something called fourths. The difference is now we can change all of those things that we're adding to the same thing. In other words, we are looking for a common denominator. And if we're going to find a common denominator to make life easy for us, we might as well find the least. Okay, I'm going to do this problem first, knowing what the least common denominator is, and then I will show you how in every case you can find that least common denominator. So the least common denominator has to be the number, let me start that over. A common denominator for the denominators that we have has to be a number that all of these go into. Okay, it's just like dogs are animals, cats are animals. You're looking for a bigger category. So I go, all right, all of those 3 numbers go into 24. So I'm going to put 24 down here. And this fraction will become, the first fraction is going to be the first fraction in the second row, second fraction will be second fraction, third fraction will be third fraction. So we can keep track of those fractions. Uh-oh, we made a change because we changed this denominator from 8 to 24. So we made one change. In math, remember the previous thing to remember, changes come in pairs. So we changed 8 to 24 by how? By multiplying by 3. That tells us exactly what to do to the numerator to change it to our new numerator, because we want to change the denominator and the numerator by the same thing. So 8 times 3 gives you 24. 3 times 3 is going to give you 9. So we have an equivalent fraction there. So what did we do to go from 12 to 24? We multiplied by 2. So that tells us we're going to have to multiply the numerator by 2. And we would get 10. And then finally, our last fraction, how did we change that 4? To get to 24, we multiplied by 6. So that tells us how we're going to have to change this numerator by multiplying by 6. And we get 6. So I'm going to point out that these 3 fractions are equivalent to these 3 fractions. But now they all have the same denominator, so now we can add because we're adding like things. So let's just finish this off. So we've got so many 24ths plus so many 24ths minus so many 24ths. What we're going to end up with is 24ths. So that doesn't change. To see how many 24ths we have, we just add 9 plus 10 minus 6, and if we do that, we would get 13. So what we have altogether is 13 24ths. Do you remember before I said when we're in R4 and we're adding and subtracting, the last step is always, can you reduce? Or another way to say that, I keep using the 2 words interchangeably, simplify those fractions that you've got. There we go, simplify. So real quick, I'm going to say, okay, 13, that's prime, that's 13. 24 is 2 times 2 times 2 times 3, and I go, there's nothing to cancel. If you can't cancel here, you know, woohoo, this guy is finished, simplified as much as it can be. Okay, let us stop this video, and I'm going to go back to adding and subtracting fractions with a little bit more detail. I just wanted you to see an overview of how it's going to look.